Today we have 4 presentations. And so first we're going to be hearing from Harsh Parekh on understanding the role of cyber hygiene in target suitability.
So hello again. So since I've already introduced myself, I'm a second year PhD, and this is one of the major topics I'm working on. Like I said, like cyber hygiene, personal computing, these haven't been that much in the focus in the literature. So quantification of how it affects organization is the overall goal. Sort of in this presentation, I'm looking at, so I'm a theoretical person, so bear with me, like routine activity theory is one of the core theories which says like there is a motivated offender, there is a opportunity for offender, like, and there is lack of guardianship. So crime happens at intersection of these three things. And I'm sort of looking at attitudes and two systems, and to sort of the overall goal is to, I'll explain in a bit. So this is the major focus. So there are typically two types of systems. Like one is reflexive, which is like automatic or habitual. So even if you do lots of training, the habitual part might or might not get affected. So mostly through trainings, you only affect the implicit or I would say reflective system where you do a lot of deliberate thinking. So yeah, it's basically information processing happens through system 1, which is reflective or habitual, or system 2, which is deliberate or through a reasoned action. So that is, and there are two types of outcomes. So there is a self-protection outcomes, and for an individual, there are self-protection outcomes, there are self-control outcomes. And these two, at least in the literature, have been very similarly defined. But there is a really distinction between how individuals would self-control for a deterrent system where you have like compliance and regulated system versus non-deterrence, non-reward, non-coercive sort of systems. So that is the focus, to study two different systems in an individual. Next up, I'm combining this with dual attitudes model. It's pretty similar to the two systems where you have implicit attitude, which is sort of activated through like lack of personal, which is like habit. So it gets activated without personal awareness, and like there is explicit attitudes which is through a conscious decision making. So in general, the security studies have seen that one of the attitudes play so for example, if I'm exposed to certain kind of malware before, I'll have a decision making to not get exposed next time. But it so happens like the dual attitude model says both the attitudes stay, but it is just contextual to what people choose at the time. So if I have to give a quick example, if I drive to school daily following the same route, it is habitual unless I realize, oh, there is a construction going on, and then I make a decision. So I'm sort of following my habit till I realize the decision. So it's basically implicit and explicit attitude, both are there up till very end, and then person makes decision towards the end of it. So yeah, this is the model. There are two parts to it. The goal is to study how someone having implicit attitude or explicit would make them more suitable or more suitable target, I would say. So, and I mean, it is very hard to capture cyber hygiene because of there's plethora of things in it. So yeah, I mean, that is one of the challenges of this research, to capture cyber hygiene completely. There's not much literature about it, but this is like my model. I won't go into details of it, but yeah, the overall goal is to say, even if you train, are you going to affect only explicit attitude? But what if 70 or 80% of the times people just do by habit. Like, so trainings are not really helping if people just use their implicit attitude. So yeah, so habituation and that kind of things could work instead of trainings. Yeah, so that's all. Thank you.
All right, for our next presentation, we've got a group presentation with Emily Adams and Brian Chase, and they are presenting on a position paper, Iris Data Integrity and Threat Models. Welcome.
All right. So I just flew in from the Caribbean last night, so this is a little bit of a change with the cold weather. So I'll try to maintain my focus. Hello, welcome. My name is Emily Adams. I'm a principal security analyst for CACR. Go ahead, and Brian.
I'm Brian Chase. I'm a security analyst, formerly for CACR, but now I'm working for OmniSOC.
So we're going to just briefly go over a work that we did in conjunction with one of our colleagues, Ishan Abanit, and then also with collaboration with ISI from Southern California and Renzi at UNC Chapel Hill. All right, our focus here, here we go. We worked on the IRIS project. So in essence, our goal was to assist researchers with proactively designing scientific workflows. Our contribution was really to identify an approach of threat models for both non-malicious and malicious activity that could threaten scientific data workflows. Yes, and basically, we worked with the researchers who had developed a system called Pegasus. I don't know, has anybody used this system in order to, oh, good, we have a couple, great. We used the Open Science Cyber Risk Profile, OSCRP, to identify non-malicious threats, and we used MITRE ATT&CK Knowledge Base to identify malicious threats, with the goal of, through this methodology, that future scientific workflows could benefit from maintaining their heightened sense of security where they know where to look for those threats. Here's a quick diagram of how we applied the OSCRP asset inventory. Basically, OSCRP is a number of steps to address cybersecurity in scientific workflows. We adapted it slightly to identify key points within the scientific workflow using SWIP as a kind of a background in order to identify the non-malicious and malicious threats within these workflows. Here, I'm going to give you two excerpts from our work. This is the non-malicious threat analysis. As you can see, we dealt with concerns for the data. I hope you guys, can you guys see the slide okay? Okay, I do, okay, all right, great. In addition, vectors of attack and failure. Now, one thing to note here is that the vectors of attack really aren't necessarily malicious attacks as labeled. We pulled that language in from OSCRP, so this would be kind of more generalized threats, non-malicious threats. Second, we then did the analysis of malicious integrity attacks using MITRE ATT&CK database. We focused on the threat actor, we get in the shoes of the bad guy, if you will, needing to manipulate the data, affect the scientific workflow, thus affecting the scientific results, which then, if a researcher uses a previous researcher's work, can also affect their work as well. Here you can see in the MITRE ATT&CK, if people are familiar with it, we have the techniques. We included the OSCRP identification of assets, attack type, data integrity concern, and scientific workflow impact. With this, I'm going to hand it over to Brian. He has a history of research in IT, and he's a great colleague to work with, so go ahead, yes.
I think but my main contribution to a lot of the work that we were doing is I'd just come over from the research technology group at Indiana University. And I've had a lot of work with like massive data sets and collaborating with scientists and researchers. You know, as any of you know who have worked with research data workflows, these present a lot of challenges in terms of maintaining data integrity. There's lots of different points where something can go wrong, either because of just, you know, like a faulty hardware, faulty system, faulty networking, or potentially a malicious actor coming in and causing problems. In most cases, it's not clear whether a corruption of data is malicious or not. You know, one of the things we were trying to do in going through this is figure out if there are examples of things that we could sort of think of where it would be clear that the manipulation or the integrity issues were corruption, or were corruption from a malicious actor. There's a couple things that we kind of came up with. One is potentially if the data files are directly modified and the attack leaves some sort of signature within that, that might be one way to identify it. Another sort of common, or another possible one is something like a ransomware attack where the data files are being encrypted. You know, if you just look at the file, you might not necessarily know whether or not that was just like a random error or something that happened in there. But if you look at the entropy of that data, if it's encrypted, it's going to have very high entropy. So that could be one sort of way that you could identify that it was a malicious attack. The sort of main takeaway is the safeguards that are put in place, like cryptographic checks on the workflows. It's going to catch either malicious or non-malicious issues. But maybe for certain potential future research, you know, if there's a way that could actually sort of like simulate malicious attacks, see if there are identifiable signatures to those attacks that can be used, and also maybe explore the idea of looking at entropy for looking at data that's been maliciously encrypted. And sort of like the main benefit from this is that whether your data corruption is malicious or not is going to sort of dictate how you deal with the issue. If you know that it's malicious, you're going to want to contact the security team. If it's something that's, you know, could be explained by technical error, then you would just sort of contact your systems and support people. And I guess that's all I really have to say about that. I think the work that we did, there are some additional avenues that could be pursued for further research. So thank you very much.
So we're running a tad bit ahead, so if anyone has any questions for Emily and Brian. Yep.
Yeah, if you want to. Yes, and yes, I went through every single tactic and technique in the MITRE database and analyzed it for validity. So, good to go? All right.
Thanks again.
Thank you.
Great, and our next presenter is Feng Cao from NCSA at the University of Illinois. That's where I work. He's presenting on data anonymization proxy for interactive log analysis.
Good morning, everyone. It's my pleasure to talking to you here in person. I'm Feng Cao from NCSA, and today I will talk about a data anonymization proxy for interactive log analysis. First, I want to show that the operational log that we collect at NCSA and at any system is very variable. These logs allow us to have insight into performance, security, and failure of the large-scale system. And these logs that we collected are a variety, for example, including network flows, system log, forensics analysis, and also the honeypot log. So these logs are usually semi-structured, difficult to analyze automatically, and there are a lot of sensitive data in such a log, so there is a huge privacy concern in sharing such a log. And also there's a technical reason as well, because these logs are very large, in the order of terabyte or even petabyte. So to share that with an interesting partner is a difficult problem. In the last few years, we have seen an exponential growth in such a log, and that further makes the problem of log sharing more difficult. And I want to say that we have seen a national interest in the log that we are collected, because there are researchers in different domains like reliability or security. They want to do the modeling analysis to understand the security attack and understand how failure happen in such a large-scale system. So there is clearly a big gap between the data that we have and the model that can be developed. And the gap here is that it is infeasible to share such a log in a real-time, sanitized and structured manner while preserving the security, privacy, and auditability of such a log. So what we propose here is a data anonymization proxy, which has three key characteristics. First, it allows an on-demand streaming data anonymized extract, transform, and load pipeline, so that anyone with correct permission can interact with the log on the disk as if such a log has been already loaded into a database. Second characteristic is that we provide an interactive interface with a familiar SQL language, so that anyone from data analysts can interactively explore the log, to the researcher can evaluate, execute, and reproduce the machine learning model on the log that we share without accessing the entire log data set on the disk. Finally, what we are doing is to secure the access to such proxies using a zero trust and token-based approach using our own Sky Token project at NCSA. So what makes these proxies different from the existing approaches? If we look at the two dimensions of the current log analysis approach, one dimension is to using the batch and the batch analysis and streaming. Another dimension is to use a compiled language to do interactive analysis. So at the bottom, you can see we can do the batch analysis of such a log using traditional language such as Java, or use streaming using Spark. But all of these are not suitable for the interactive analysis, and they do not allow the on-demand and real-time sanitization of the sensitive data in the log. So what we propose at the top allow both the streaming analysis and interactive execution of SQL script while preserving the privacy of the logs. And this is the architecture of the system, which I'm not going into the detail, but essentially we determine the sensitive data field in the log and allow the user to write the third-party plugin that can be run in the PostgreSQL database. And such a plugin will either replace or mask out the sensitive field, or replace such a sensitive field with a machine-generated data, so that it looks like the real data for the purpose of analysis. So it's coming to the end of the talk. I want to quickly show a brief screenshot demo of what we have been working on. So the central component here is a PostgreSQL running the foreign data wrapper to sanitize the log. And on the left, you can see the raw log on the disk, which is a zip log that we collect more than 100,000 of alerts a day and a few hundred megabytes a day. What the external collaborator can do is that they can interact with such a a zip log on the disk through our SQL interface. Either they can do it in terminal, which is very easy to integrate with existing script, or through the web. And in this example, they can run a SQL query which return a list of IP addresses and the connection made from such an IP address. And as you can see here, it's a little bit small, but the last two number of the IP has been masked out. So they can still do the interactive statistic summary on the data on the disk while preserving the privacy. And all of this is done in real time, transparent with the researcher. So this is a very, very useful thing for them to do. In summary, the problem that I addressed is the data and the model gap due to security, privacy, and policies. And the system that we propose is a data anonymization process to provide the on-demand streaming SQL analysis of the log while preserving the privacy of sensitive information in the log. And this system is secured by the token-based authentication. So if you have any question or feedback, please ask the question or send me an email. Thank you.
Do we have any questions? Here.
Hi, is it obvious to the end user what data has been anonymized? Right here.
So your question is what is obvious to the end user that what data has been anonymized, right? Yes. So that can be defined before the data set has been actually exposed to the user by a list of sensitive fields. In this example, it is the IP address which need to be anonymized. And that can be annotated in the Postgres by querying the structure of the Postgres table that is being exposed to the user. And they can see that in the table structure and also see that while they query the data, you can see that the sensitive data has been masked out with the XXX.YYY character to preserve the privacy of the real IP address.
Any other questions?
We have a question from Slack.
Okay.
This is Sean. If you're doing summary statistics, why use anonymization rather than differential privacy, which is really designed for statistical output?
Yes, great question. So differential privacy allow a guarantee of data privacy with a certain threshold. But what we are doing is slightly different from differential privacy, is that we provide the real-time data sanitization for interactive data exploration. So the purpose is slightly different, and we allow the interactive data exploration while preserving or masking out the sensitive field. Does that answer your question?
Yep, he said thank you.
Okay, we can catch up offline.
So in this example, you're actually just sanitizing, masking it, right? So you lose the relationships between the various connections for the same host. Are you able to actually pseudo-anonymize the IPs as well, or just mask?
I see. So your concern is that we lose the relationship by masking out the number in the IP, right? So to preserve the relationship between the IP, for example, to determine what exact IP has opened, what port, right? What they can do is that in the future, they can write their own relationship analysis plugin in the PostgreSQL. So by doing so, the researcher can bring the model to the data so that the model can be executed on the data that we provide. And what's showing here is just the summary of of what the model, of what the people, external people could see. But the actual model to analyze the relationship between the IP can be run on our Postgres engine and would reveal the exact relationship between the precise IP address. Does that answer your question?
Yes, thank you.
Okay, thank you.
So you're assuming that a sort of complete knowledge of the structure of the logs, is that right? So in other words, can you anticipate all the fields that could have privacy concerns? I mean, what if there's a name in there or something like that, not just net ID?
Yeah, what we assume here is that the structure of the log is semi-structure, and the set of the sensitive field need to be determined beforehand and agreed upon before running through our proxies. And actually, the set of what fields are sensitive is not too large, and it is very well defined for different kind of domain. We are clearly defined what field is sensitive. So that can be agreed upon and put into the plugin before running our proxies. Yeah, thank you so much.
Our next presenter is Yunhei Feng, and he's presenting on your screenshots tell more than you think. Privacy leakage in screenshots shared over Twitter. And I just want to note that Yunhei came here from teaching, right? So out of the frying pan and into the fire. Thank you so much for coming to our summit this year.
Morning, everyone. So actually, I'm not, came here from teaching. I just give a presentation at Ladi Hall. Yeah, so it's a research talk. So I'm so happy and honored to be here to present our ongoing work about the privacy leakage in screenshot shared on social media. My name is Yunhei Feng. I'm a first-year assistant professor in computer science from University of North Texas, or UNT. So at UNT, I'm leading the responsible AI lab. So our mission focus on the developed model or algorithm to achieve the important features in responsible AI, like fairness, transparency, explainability, security, and privacy. So we're also interested in studying the societal impacts of the AI. So here is a photo of our first week lab meeting. As a meeting, I asked the lab members, say, how many of you have the experience of sharing screenshot on social media? Actually, 5 over 7 said yes. So today, we would like to show, the privacy leakage on social media. So here are 2 examples of the screenshot shared on social media. The first one is show the installed app, and the second one is show the Uber screenshot. It is for customer support. So for the first one, the installed app, actually the existing research had demonstrated that a lot of sensitive personal information like your gender, religion, the age, or even sexual orientation can be inferred from which kind of app you install. And for customer support, like here, it reviews your real-time location information. It's also a sensitive one. So in our study, we collect the data using the Twitter streaming API, which allowed the developer to specify the keyword, like the track. So we use the keyword of the screenshot in our study to collect more than 30 millions of the tweets. So all of the tweets are stored in JSON file. The JSON file is kind of the key value pair. So next, we would like to show which kind of topic people mention when they tweet the screenshot-related postings. So by applying the topic modeling, we find 10 topics. For example, we find some topic about bypass bans, verification, and also about emotions and customer support, and even harassment, and game, music, and time image. So we find the customer support a really important topic. By analyzing the mentions, we can see people mention a lot about the Amazon India, Amazon Help. It is for customer support. By analyzing the hashtag, we find most of the screenshots are talking about the game. We also labeled the screenshot image. Like the first 3 popular labels of the screenshot are screenshot, test, and font, which means that in most of the screenshot contains a lot of test information. And through test information, many types of sensitive information may be leaked. So here's more example of the screenshot privacy leakage from mobile devices. So we can see different type of the screenshot privacy leakage, like the ID of your devices, IMEI, it's International Mobile Equipment Identity, and also people may tweet their home address online. By extracting the text using like OCR technology, we can analyze the email and identify the phone number. Besides that, many of the screenshots contain the status bar. From a status bar, we can infer like the cellular carrier or even like some kind of the apps running at backend. Some of the screenshots may also review the bank account. Here's the examples about screenshot privacy leakage on desktops. So in the topics, the image here, actually the user would like to show just one browser tab, but at the same time, we can observe the other browser tabs. We can also, in some of screenshots, we can also observe the bookmarkers and the browser extension of browser plugins, and which kind of the software installed on the desktop. So in our study, we conclude all of the type of the privacy leakage into 7 groups. So actually, it is a user study. Like we have the type of the screenshot. The privacy types like the phone information, the apps, the personal sensitive information, the social, finance, location, and others. At the same time, we ask our participants to label, whether they think it is intentional or not intentional, like to leak the privacy. Besides the user study, we also develop models to automatically detect the privacy leakage on screenshot, like to detect the status bar, to detect whether it is the screenshot of the contains a lot of text, and also detect the map, detect the conversation. So now we are still working on the model to automatically detect the different type of privacy leakage. Finally, we did another study about the tweet deletion behavior. Like we are very curious about whether people are aware of the privacy leakage through screenshot. So we compare the deletion frequency for 4 types of the tweets. The first one is the general tweets. It can be any kind of the tweets, but it contains message, contains image. The second one is general tweet without image. And the third one is information screenshot in the tweet, but also contain an image, at least one image. And also one screenshot without image. So we find that they mention the keyword screenshot in their post. It's more likely for them to delete it and they delete the tweets like that more frequently. So, which implies that people are aware of the privacy leakage through the screenshot tagged tweets. So here's the takeaway. Your screenshot tells more than you think. Be careful, about the screenshot if you would like to make it public to everyone. Thank you. Yeah. Thank you.
Hello. Did you notice if there was any difference between, say, an Android user or an Apple user in your data?
Yeah, actually, we propose a solution to detect both Android and iOS, because Android and OS, they contain, their layout and the altcoins are different. We can detect it, and based on the collect the data, the JSON file, they also contain the information about Android and iOS. So it is an interesting question, but whether we can find some difference regarding the privacy leakage, but we haven't do it. So it is a good point. It is a good point. We will cover it. Yeah. Thank you.
Did you do any analysis on what the difference between somebody taking a full screenshot versus a cropped screenshot?
Yeah, we observed that, very small amount of the screenshot, they are carefully cropped. Means that, for example, remove the status bar, or, using, just to show the elements they would like to show. Yeah, so some users did that, but it is just a very small amount of them. Yeah. So most of them just capture the screenshot and post it.
Did you notice any metadata that was still being produced? I know a lot of the main social media platforms have been scraping that out, but did you come across it in this research?
Yeah, that's a good point. Actually, we checked whether we can find some privacy leakage through the metadata, but because the data collected in 2019, from 2019 to 2020, so we can't observe any privacy leakage from the tweets. But the old tweets, like the tweets in 2015, may contain a lot of the privacy information, in the metadata. So, but now, Twitter changed their policy to make it private for the users.
Hi, so there are apps that can simulate things like conversations. People love to say that, here's the conversation I was having on this dating app. Have you done any analysis to check whether or not the screenshots are actually legitimate, or are they two AIs talking to each other?
Yeah, that's interesting. That's an interesting question, because nowadays people are talking about misinformation, talk about fake news. Now it's about a fake screenshot, right? So it's yeah, we did not study that, but I think it's an interesting research question to do that. Yeah, thank you for your question.
Do you have enough statistics to be able to do sort of secondary inferences, like which gender does what more, things like that?
Yeah, not really. Yeah, because we studied the whole group of the Twitter users. Yeah, we don't study a specific group of people. Yeah, but I think there will be some difference. Just like we can group people using different roles, like by gender. Using different features by gender or by which kind of the smartphone they are using, like iOS or Android. So yeah, I think it would be very interesting if we can find some difference between different group of the users.
Another sort of question about your data collection. Were you only looking at phone screenshots, or were you also looking at something like a tablet, or even, I know that you showed a desktop, but were you also doing categorization for something other than phones?
Yeah, so for this study, we mainly focus on the screenshot. We collect the data, the tweets mentioned in the keyword of screenshot. Yeah, so, but in our last study, it's about, tweet deletion behavior. So we also collect the general tweets. It is randomly sampled, all of the tweets. So it may contain the keyword screenshot and may not. For this study, we, we started general images. But that is a good question, yeah, because if we only collect the tweets mentioning the keyword of screenshot, it may also introduce some bias. Because some tweets may contain screenshot, but they did not use the word of screenshot in their post. Yeah, so yeah, we are now actually we collect new data to get it fixed. Thank you.
Okay, show of hands, who started looking through their phone to see if they could detect any personal information about themselves based on their apps? Totally, yep. All right, thank you.